In this lecture, let's get all of our chunks moving in the right direction, backwards towards our player. Before we jump straight back into our level generator class, when we play the game, everything looks pretty bland. It's actually going to be pretty hard visually to see these chunks moving in our game view if we don't have a little bit of texturing or depth to each individual chunk. Let's go add some assets to our chunk prefab just to get that little bit of depth. Let's open up our chunk prefab. With that open, we can actually go into imported assets and head into our prefabs folder in our GDTV assets. I'm not going to go too far for now. We can decorate and spice this up a little bit more later, but I'm actually just going to find this path cobblestone asset and just kind of put this on top of our cube just so we can actually see it moving in our game view. So I'm going to drag this directly underneath our model parent game object and just kind of line it up here on the left side, duplicate it with it still highlighted, slide it over, make sure we don't have too much overlapping, and yeah, I think that looks pretty good for now. I'm just going to center it a bit here, and I think we're in business. That way, when each individual chunk prefab spawns in our scene, once we actually get it rendering properly, there you go. That'll be a little bit easier to see the actual movement of each individual chunk in our game view. With that set up, let's head back into our scripts folder and open back up our level generator script. Right off the bat, I'm seeing an opportunity to do a little bit of refactoring. We've got a bit of a messy start function, so let's immediately actually just pull this out into its own method. I'm going to highlight all of this code, click the light bulb, and scroll down all the way to the bottom where it says extract method. I'll just rename this method by highlighting one, pressing Ctrl D to modify both at the same time, and I'll just call this spawn chunks. Inside of spawn chunks, I'm noticing we're doing two different things. We're both spawning the chunk, and we're also getting the float spawn position Z. So I'm noticing another chance to just do a little bit of refactoring to keep our code as dry as possible. I'm going to highlight all of this code out and actually pull it out into its own separate method. So again, highlighting all of this code, click the little light bulb, scroll down, and extract method. You can actually see here, we've now pulled out all of this logic into its own method to keep this logic dry. And when we actually set spawn position Z in our spawn chunks method, we can actually just call this new method directly. And instead of returning void, we're actually returning a float. We pass through I into this new method, use I inside of this method. It's still smart enough to know that it's inside of this for loop. And then at the very end of this method, we return a float. We return the float spawn position Z. And depending on where I is in our for loop, we can return that correct spawn position Z value. This is all doing the exact same thing as we had it in our start method, but it's keeping our code a lot more dry and readable for refactoring later on. For the sake of learning something new, highlight the first new method and just press F2. That'll give us the option to rename the method this way. This is actually really helpful because it also works in between classes or different scripts. Let's rename this calculate spawn position Z and press enter. All right, looking good so far. Let's now get each individual chunk moving. Let's use what we know so far using arrays, albeit I'm being a little bit devious in my teaching, knowing that we're going to run into some issues using an array later on. I'd like to store all of my instantiated chunks inside of an array. So let's go ahead and do that. Let's create an array of chunks. We'll just store this as a game object for now. So game object, open, close bracket. We'll call it chunks. And each individual time we instantiate a new chunk, we want to put it inside this array. One of the downsides of using an array is you can't constantly be resizing how big or small the array is. Okay, well, not too big of a problem. We haven't actually ran into any issues yet. We know we're going to spawn 12 chunks, so we can just set this chunks array equal to a chunks.length of 12. We can actually do that by setting chunks equal to new game object of an array with 12 available spaces inside of that chunks array. And even though an array is a zero-based index, putting in 12 will actually return 11 elements 0 through 11. Now that we have that array created, each individual time we instantiate a chunk, let's just call it game object new chunk equals that instantiated new chunk. We can now use this new chunk and just put it inside of our game object chunks. And once again, we can actually use I to get the right position inside of our array that we'd like to assign it to. So chunks, open bracket, I is equal to new chunk. That way, each individual time new chunk is instantiated, we just put that entire game object inside of our chunks game object array. Let's actually head back into Unity just so you can see what that looks like. With our level generator selected, you actually can't see anything exposed here in the inspector because that chunks array is actually set to private. Now, you could, of course, go back into that array, make it a serialized field, or make it public so it would actually properly show in the inspector. Or in the very top right, you can actually click these three little dots And instead of viewing things in normal mode, you can actually view things in debug mode, which will also show the private variable names at the top of our class that we haven't exposed in the inspector. So here you go. You can actually see all 12 of our chunks and each individual chunk prefab that we've assigned to it. Well, great. Now that we actually have these properly assigned inside of this array, we can get them all moving. Let's hop back into our level generator class and set that up. And because we know we're going to move each individual chunk, it probably makes sense to create some sort of float move speed. So let's create a serialized field. Let's create a float, and we'll just call it move speed. And we'll initialize it to something like 8f for now. Scrolling back down, let's actually create a move chunks method. So let's create a void move chunks method. And just for the sake of consistency, I'm going to also delete these two private keywords from our other two methods just to keep things implicit. Because we're going to be moving each individual chunk using transform.translate, we can just put that directly in an update function. So let's create that as well. Update. And inside of update, we'll just call move chunks every frame, which will introduce you to this lecture's challenge. Use a for loop to move all of our chunks backwards towards the player. Now, you could, of course, use a for each loop. That would work just fine. But for the sake of practice, go ahead and use a for loop so you can flex your new game dev muscles. Use transform.translate and our move speed variable to get everything moving backwards towards the player. And just a little bit of a hint, you can use transform.forward to help with getting the right direction. Transform.forward is just going to return a normalized vector representing the blue axis of the transform in world space. So if you recall, every single time you're in your scene view and you click a game object, you have those three different axes. That blue arrow is going to be what's actually pointing forward. So depending on how the transform is rotated inside of world space, that blue arrow will actually return that transform.forward vector. In other words, it's just 0, 0, 1 if you were to create the vector from scratch. Go ahead, pause the video, give it an honest effort, and I'll see you back here in a few moments and we'll go through my solution together. All right, welcome back. I think we have everything we need. We can just start coding directly in move chunks using a for loop. So I'll go ahead and auto-complete a basic for loop, and we can keep I at 0. But for our condition, I want to use our chunks dot capital length to get the length of that array. And then every single time we call this code block, we can just add 1 to I, so I++. Let's now get each individual chunk moving. So chunks, open bracket, I to get each individual chunk, dot transform dot translate. Inside of translate, we just need to pass through a vector 3 that we want to use. Great. We can use transform dot forward, except a bit of a gotcha. Again, we want to move backwards. So we just want to use negative transform dot forward to make sure that I'm moving backwards towards the player. Times it by move speed times time.delta time to make everything frame rate independent. And just a little bit of a performance trick. This is going to take transform.forward, a vector 3, times it by a float, turn it into a vector 3, and then times it by a float again. And in Unity, it can technically be a little bit slower to times a vector by a float. So just a little bit of a performance enhancement. We can actually times our two floats together first, wrapping them in their own parentheses to times move speed by time.delta time first, and then times it by our vector 3. So there you go. I think that's all we need. Let's head back into Unity and see if that works correctly. Before I press play, I'm just going to exit out of debug mode in our inspector. So additional little menu in the very top right and just change that back to normal mode. Let's press play and see if everything is working as intended. All right, looking good. We've got each individual chunk moving backwards towards the player. However, you can see a bit of an issue. It's just going to go onwards and forever backwards towards the player into the abyss for infinity. Before we move on, I'm going to go a little bit crazy with this shadow here on my king. You can kind of see that it looks like a little bit of a skeleton. We're going to handle a lot more shadow-related lighting and rendering issues a little bit later on. But for now, just for the sake of my own sanity, let's actually just get that shadow resolved so everything looks a little bit more clean on our level. So assets, if you go into your settings folder, you can find the rendering asset that we're using at the moment, which is this PC_renderer.asset. Excuse me, not that one. It's actually this one here, this PC_RP asset. Scroll down where you can find the shadows component. And then if you just actually drag your normal bias from 0.5 just all the way to 0, you can actually see that shadow just cleaning up all of those little teeny tiny holes in the shadow. I think that looks a lot better for now. Let's go ahead and unclick pause. Let's see if that works properly. Because this is a rendering asset, you can actually modify these things while in play mode and it won't actually reset. All right, great job on this lecture. When you're ready to move on, I'll see you in the next one.